Welcome to another new video of interesting math problem on our channel Math Solutions for You. Please do like, share, comment, and don't forget to subscribe to our channel. Today's problem is a familiar topic on time and work. The problem states that 2 men and 2 boys can get a job done in 80 minutes. 6 men and 4 boys can do the same job in half an hour. How many minutes will it take 4 men and 2 boys to get the same job done? We will solve this problem applying what's called unitary method. But here we have basically, 2 different categories, men and boys. And before mixing them together, we'll consider their capacity one by one. So we start with assuming that 1 man can do the job in m minutes. And this is 1 man working by himself without any boys. And similarly, we make the assumption that 1 boy working by himself, again there is no men, just the boy himself, can do the whole job in b minutes. And from this we can derive 1 man can do 1 by mth part of the job in 1 minute. So we are basically now considering what fraction of the job does 1 man accomplish in 1 minute working by himself. And we do the same thing for the boy. What fraction of the job does 1 boy accomplish working by himself in 1 minute? So that will be simply 1 by b. Next, we consider the effect of having more than 1 man. So instead of 1 man, if I have say p men, so a greater part of the job now gets accomplished, right? So p men, and again this is p men working by themselves, no boys. P men can do p by nth part of the job. So now a greater part of the job gets accomplished in 1 minute, and how much greater? Well, we multiply by p. So that's the multiplicative effect of having more men. And the same thing holds if we assume that there are q boys, then q boys can do q by b part of the job in 1 minute. So now we consider what happens when we have p men and q boys working together. So then an even greater part of the job gets done in 1 minute, and it's an additive effect this time. So that additive effect is captured in p by m plus q by b, that part of the job being done in 1 minute with p men and q boys working together. So p men and q boys can do the whole job in 1 divided by, and then in the denominator we have within parenthesis p by m plus q by b minutes. So this is how we basically tease out the effect of, or the additive effect of having men and boys working together. And we have basically made some generic assumptions of p men and q boys, and this will just help us solve the problem going forward. So we clean up some space here to make room, but we carry over this important result that we derived in general, that p men and q boys working together can do the whole job in 1 divided by, within parenthesis, p by m plus q by b minutes. So once we have this generic expression, it just comes to the matter of substituting p and q and getting 2 equations. So it's given that when P equal to 2 and Q equal to 2, then the time taken becomes 1 over, and in the denominator we have 2 by m plus 2 by b, because P equal to 2 and Q equal to 2, right? And this is given as 80 minutes. So we can write this equation, and from here we can obtain 2 by m plus 2 by b is equal to 1 by 80. Next we consider P equal to 6 and Q equal to 4, in which case the whole job will be accomplished in 1 over, again we do the substitution, P is 6, so we have 6 by m, and Q is 4, so we have 4 by b, so 6 by m, so 1 over 6 by m plus 4 by b, and that's given us half an hour, and half an hour in minutes is 30, because we are doing everything in minutes here, so we want to make sure that we have the same consistent unit of time. And then from this we can write 6 by m plus 4 by b is equal to 1 by 30, and then if we divide both sides of this equation by 2, we obtain 3 by m plus 2 by b is 1 over 60. So we have now two nice equations. They're simple, we have two variables. It just comes to a matter of solving this. And if we subtract the first from the second equation, we basically get 3 by m minus 2 by m. So the 2 by b gets cancelled out, right? And then on the right hand side, we have 1 by 60 minus 1 by 80, which comes to 1 by 240. So we basically get 1 by m is equal to 1 by 240, from which m comes simply as equal to 240. And once we have m, we can also solve for b. So we just substitute the value of m equal to 240 in the very first equation of 2 by m plus 2 by b equal to 1 by 80. So now we have 2 by 240 plus 2 by b is 1 by 80. And from this it becomes very simple to solve b. B comes as 480. So now consider what we have been given to find. We have 4 men and 2 boys. So P equal to 4 and Q equal to 2. So what's the time taken in minutes? Well, we know that the time taken by minutes will be 1 over P by M plus Q by B in the denominator, right? The very first expression, the generic expression that we obtained for P men and Q boys working together, how many minutes it take to do the whole job. So we just substitute. We now know everything. We know P, we know Q. We also know M and B. We have just solved for those, right? So we just substitute in that expression for the number of minutes, and we have 1 divided by, within in the denominator we have P equal to 4 and M equal to 240. So P by M becomes 4 divided by 240. And the second term in the denominator, Q by B, here Q equal to 2, and to B we have just solved for B equal to 480. So 4 by 240 plus 2 by 480 in the denominator, and if we multiply both the numerator and the denominator by 480, we get 480 in the numerator, and in the denominator we get 8 plus 2, which comes to 480 divided by 10, which is 48. So the correct answer in this case will be option D, 48.